Hello everyone, and welcome back to my SP2 channel. We're going to be looking at valence bond theory, and there's a little bit of practice at the end for you. Okay, so starting by kind of introduction for the valence bond theory. So when you're thinking of the Vesper model, it is always helping us to predict the molecular geometries of our molecules, but it's not going to help us to understand why and how the bonds are being formed. Now, the valence bond theory is actually combining all the details that we know from the Lewis structures with our atomic orbitals, helping us understanding the concept of bond formation. Okay. Now, in this theory, the bonding electron pairs are going to be always concentrated between the two atoms, right? But we also have the non-bonding pairs that is going to be like taking specific regions in the space of our molecules. Okay. Now, the covalent bonds, we have heard about this one before, right? So the formation of these covalent bonds is going to happen when we have the atomic orbitals that are actually overlapping. So be careful with this term. If you hear about overlap between the orbitals, that means the electrons are going to be allowed to interact, and they're going to be always opposite spin that are sharing their space between the two nuclei. Okay, cool. Now, let's take a look at some examples. Okay, I'm going to start with something that is very simple, something like hydrogen molecule. So if you're thinking about formation of hydrogen molecules, we're going to have two hydrogen atoms. Each is going to have one s orbital, right? So these two 1s orbital are going to overlap, as you can see on the picture. And that's how we can form the bond between the two hydrogen atoms, right? So the overlap that is kind of shaded in the pink color is presenting your covalent bonding. Another example is something like HCl formation, which is hydrogen chloride, right? And what I have here is I have a hydrogen molecule, a hydrogen atom, right? Not molecule, and I have a chlorine. So hydrogen has one s orbital, and chlorine valence orbital is going to be the 3p. These two are the ones that are going to, overlap. They're going to share their electrons, right? And that's how we can make a bond between hydrogen and chlorine, as you can see on the picture, right? Another example is something like Cl2 formation, right? That is our chlorine gas, right? What I have here is I have two of the 3p orbitals. Each have one electron, just a single electron, and they're going to share that between the two chlorine atoms, right? That's how we can form a bond between two chlorine atoms. Okay, cool. Now, let's go a little bit kind of deeper in the discussion of formation of the bond with respect to the distance between the two atoms. Okay, the example that I have for you is hydrogen molecule. Okay, so if you look at what I have on the slide, you've got your y-axis, which is our energy over here, and this is going to be the x-axis, which is the distance between the two hydrogen atoms, right? So take a look at what we have at the beginning. The energy is pretty high because the two atoms are too close to each other. We have too short distance between them, right? And that is going to be pretty much repulsion, right? Or repulsive forces that we have between the two atoms that are making the energy of the molecule pretty high, right? Now, as you pull them apart, a little bit increase in your distance, you can see that the energy is kind of going down, and you're going to get to this point, which is like amazing, right? That's like the lowest energy where we have the optimized distance between the two hydrogen atoms. It's about 74 picometer. Picometer is just a unit for the distance, and it's kind of balancing between the attractions and the repulsion that we have between these two atoms, right? So that is pretty much the bond distance, right? That's like the best distance between the two hydrogens. Now, as you pull them apart, right, as you can see, the distance is kind of getting larger, right? The energy is kind of going up, right? And you would get to the point that the two atoms are completely separated, right? And that is pretty much, you're destroying your molecule, right? You're breaking your bond, right? And that's why the energy is kind of going up. So this would be a very simple but very effective way that we can think about formation of the bonds and how the distance between the two atoms is kind of optimizing the energy of them. Okay. I hope that makes sense. I've got a practice for you on the next page. Follow me on the next page. Okay, so here's the question. What are the orbitals that are expected to overlap if you're trying to bond, right, to make a bond between fluorine and chlorine in your FCl? So we know that fluorine valence electrons, right, the one with the highest energy is going to be in 2p. So I can kind of cross out option A, right, as well as option B, right, because we're dealing with 2p. Now for chlorine, is going to be one row, below fluorine, which is going to be 3p, right? So you can cross out choice C. So D must be our best answer. Okay, excellent job, everyone. Thank you very much for watching this video. If you like it, give it a thumbs up. I always would love to see that. And there are going to be a lot more coming up soon for you. Enjoy the rest of your day and bye for now.